Alright, so yeah, we're live. So it's late. It's pretty much in the evening, so I'm gonna keep this short. And basically, I wrote a plan basically, but just the main thing is write a help for function and maybe use that for symmetries, but that's kind of like the idea. Because right now at the end of last stream, we noticed that everything compiled, right? So git log. So we basically kind of last stream was kind of this commit, very short stream. Like with what we did, we just copied mcts.ts and train.ts from connect 4, and then the only kind of it basically compiled as is, with one exception, which we had to in our apply move function, we had to pass in a game state second argument, right? Because we first wiggle this, make sure that it's what just happened. Anyways, wait, what? What is going on? Let me just quit the terminal app. Something weird happened. Let me just let me just make this big. So we kind of so we just kind of added the game state parameter into an argument into apply move, because when we're applying the move, we need to because of the historic idea to encode velocities, right? Like the game state, the difference between this and connect 4, one salient, one kind of major difference, which BumperCoins has an additional property called last or prev game state. So the game states basically kind of points to the previous one. So because of that, when we're applying the move, we have to kind of point, it's basically advancing the game state from game state A to game state B. So the new game state B needs a back pointer to a game state A. So that's why we have to kind of pass in a game state too. And since apply move is destructive, there is going to be under the hood some cloning involved of a game state, because we have to have game states A and B where B points to A. We can't just have A become B. Then we lose some history. So that's why we need a past game state to kind of point to. So aside from kind of doing that little kind of fix in the function invocations, everything else just compiled, which means in theory, if everything was kind of done correctly for BumperCoins, then all I have to do is node train.ts, maybe change some constants here and there to and then it should just work. Now that's kind of assuming every component just kind of works. Then train.ts and mcts.ts, they just kind of leverage the game state in net.ts to just make everything work by magic. So as long as net.ts and gamestate.ts, and those are the two main files, are correct for BumperCoins in this BumperCoins bot repo, then we're done already. So I think before actually running the training procedure, I think it might make sense to just test out symmetries, which we just did, because I feel that it might be just good to test out symmetries too, maybe in our scratchpad, just to verify that the cloning, because there's one wrinkle I just kind of realized in symmetries a few streams ago, I think second to last stream, where when I was sorry maybe even one before, in the game state transformations, I kind of realized that we have to also transform past game states. So I just want to make sure that that's done correctly. So I think that at least that was one of the things which I was least convinced on that I did correctly. I was pretty confident in everything else. So that's why in my plans for today, just test out symmetries. Well, maybe today we might not finish it. Maybe we might just test out the game state symmetries, but then the policy symmetries, well, we'll see how far I get, because I do want to keep this kind of short. So anyways, right now I will just take a break and just eat some cheese. It's yeah, it's important to do that. So in GameState, I'm gonna add a method called like print GameState discretized or something. And I opened up net.ts file too, so I can kind of copy some of the discretization logic that it uses. Yep, good stuff. Okay, so I just kind of like wrote, like, just kind of create this new function called print discretized, which basically just kind of converts our game state to like, it just does a console.log. Basically, like, if you do console.log in game state, like, you saw what happened in VS Code when we debugged, right? Like, we get like the fixed points, like, we get the fixed points raw value. Like, we don't actually get some nice coordinates, right? So, yeah. Let's just kind of like see, like, refresh our memory as what net.convert does. So convert basically, like, let's only do the coins for now. Actually, let's just kind of specify that. Print coins discretized. Print coins discretized. So for each coin in our coins, let's just get the coordinates. We have to export this discretized. So we need to get that, like, export that. Okay, just like that. So now we've defined that function. Oh, do we have fixed point? Yes, we do. Okay, good. So we have the, so now we just need to define image stack of the, or wait, no, instead of image stack, it'll just be an image, right? Just an image. 2D number, right? Okay, just like this, right? I think this is it. Log image. And we're done. So for all the coins, we just get the coordinates. And then we simply just, you know, the first one's the row, second one's the column. So we just kind of like get a visual overview of the coins. Now this like kind of like, because we compressed our planes, we kind of lose information about like which coin belongs to which player and which coin is the king or not. It's just the coins, but oh well. I mean, yeah, it's purely for debugging. It's like very logic neutral. It doesn't affect any other code. It's not going to be used anywhere else except for Scratchpad. Intended to be used to aid in debugging. Okay. Great. So now we have this. Let's just open up so remember Scratchpad, since that's kind of like what we're doing stuff. Okay, so now we kind of like did some stuff there. Let's kind of comment that stuff out. Let's do some more stuff. So we have a game state. Now we're gonna call this let's just call this GS. Then what we want to do now is let's apply a move to it, right? Let's okay, we have to first find the king coin. I think I remember doing this once and deleting it on a stream. Oh well. Let P1 king, or let's call this card player. Actually no, P1 king coin ID string equals to something like that. And for let's coin of gs.coins. If wait, what? Why did it not open like that? Wait, what? If coin.is P1 and coin.is king coin ID equals coin.id. Okay, perfect. So now we have the king coin ID, right? So now we can build a move. Let P1 king coin move equals to new move of the coin ID. Oops. Coin ID, and then the move ID. Let's just like choose a move ID. Let move ID number equal to which directions do I want to launch it? Okay, let's recall our thing. So we're gonna take this king, and let's just launch it. Let's launch it straight. Let's just launch it like a little bit forward. Maybe it'll hit this, right? Let's just launch it directly ahead, like full steam ahead, right? So that is a move ID of 0, right? Or actually, let's do a move ID of 7 to make it go down there. And this is here and that's there, then it shouldn't really touch. Yeah, it shouldn't really touch this, I think. Or actually, no. Let's just take the first coin, this one, and launch it here, because that's actually a move I would make if I were playing a game. Let move equal to new move. Let's just call this gs dot coins of 0, like the very first coin, which I assume is going to be this one. And then the move dir, let's just kind of like send it to this direction, which is like 1. The move ID is 1. And then let move ID number equal 1. Move ID. Let's kind of export this function. Like that. Zero and then Y for 1, right? Let me see how this one is used again. This move velocity function. Right here. So when you're doing get policy and value, we're getting the move velocity, right? The move velocity. And then when we build the move, we're doing 0 and then 1 for X and then Y. Let's just see other usages. Nope, just 2 usages, that's it. First one is here, where we're just using it, which we've seen already, 0 and 1, line below. Next one is a definition, and that's it. That's the only ones we have. Which means we can just kind of like do the exact same thing, like 0, and then, oh, this one should be 1. Just like that. So now we have our move. And now what we want to do is we want to apply this, right? So now let's let gs next GameState equal to gs.clone, right? This is what we're going to do. And actually, let's just take this and let's kind of open Monte Carlo tree search too, right? Search for clone. See this line right here? So what we're doing is like we're taking the next game state and it'll be called like the clone, and then we apply move on the cloned game state. Cloned game state dot applied move, like to make it like the actual, so we don't destroy the original one. Just like we're doing there, let's kind of do the exact same thing here, right? So gs next is a clone, right? And then gs next dot apply move. So gs next dot apply move. Just kind of copy that line here. Apply move. F the move. The move. And then the back pointer to the previous game state, which is just gs. Just like that. Okay. So now what I'm gonna do actually is let's just stop here and let's do some printing. Console.log. Wait, sorry about that. Of gs next dot and then that print thing. That. Wait, no, I don't have to console.log it. It itself is enough. It has the console.log built into it. Just that. Okay, so let's print the next one. You know what? For good measure, instead of that, let's kind of do, sorry about that, prev game state. Yeah, let's print both of them. Okay. So now let's just do TSC, compile scratchpad. Ah, there's some errors. Okay, some bullshit errors. .ts. Huh? Did I not make that exportable? Too cluttered. Line 8. What? What is this? Oh, the file is GameState.cs. ./net. GameState line 50, 1150. Ah, yes. And then scratchpad.ts. Oh, the actual ID, right. The coin's ID. Now it should work. Great. So now node scratchpad.js. What? Okay, I'm gonna open a VS Code. common JS, like some kind of like net.ts line 89. What? Status, get diff. Let's do a git stash. Wait, no, I can't because of the scratch pad. Git ignore. Let me actually delete this scratch pad. I'm gonna git ignore. Git status. Git stash. Or wait, no, git. Never mind. Git restore. Git ignore. Status. Diff. Okay, so there's nothing wrong with an import. I don't see anything wrong with this. It's just a straightforward thing. We're just adding 2 exports, nothing too crazy. So whatever like issue must be in Scratchpad, right? Oh, is it because we have like two lines? Like, can we not like do it twice? Separated by a comma, okay. Okay, so this compiled. Just run it. Wait, no, sorry, what am I doing? Here. And it's done. Debug console. Oh, output, sorry, wait, output? Wait, what? Well, let me just get rid of these breakpoints. Debug console. Run debug. Okay, so now we have an issue here. Line 21. Okay, back to debugging. Back to debugging. GameState, move ID. Cannot read properties. Okay, so line 21, 0. Oh, because coins is not a dictionary. Yeah, okay, that's the issue. So I'm being really stupid. I should have just done the king coin stuff, right? GameState. Just an array of coins. We know that is the 0. Wait, what? Coins. What? Okay, this should be very elementary. I don't understand. Why am I being dumb? What am I missing? Okay, so this one works. Move ID works. Okay, step into it. Oh, reference error. Wait, no, that's from the debug. Copy that. Paste that there. Just like that. Now let's set the debug here. Oh, wait, sorry, I have to compile this first. I'm being really dumb. I have to first compile it. Okay, now let's run debug. Let's remove velocity. Okay. Ah, so here's where the error is. Print coins discretized at 150. GameState at 150. Oh yes, we have to populate this with all zeros. Yeah, okay, that's very dumb of me. Like if you look at our image, right? I mean in our convert image, whatever stuff. To first like push it. Right now the list is just empty. We have to first pad it, like just create dummy zeros, right? It's like that. So then for the number of rows, so that's like the y dimension, the size, like how many rows we have. That's like the depth, the height, and then the width, like we have to build the rows. You have to push 20 or 15 rows, right? Number of rows is 15, I believe. Yeah, 15. And then number of columns, just that, and we add it to the image. That's the word, the name image is already, the variable name is already correct. It matches. Yeah, that's it. Yeah, this should work. All right, we gotta compile. We've got to compile. Now that we compiled it, let's go back to Scratchpad and let's test it out. Just turn this off. Okay, done. Debug console. Okay. Okay, that doesn't look good. Okay, well, let's actually do it. Let's do it let's do it from the terminal, right? me just clear this. Okay. So then here's like the first one, right? So the first coin, 0, 0, so it's 3 zeros, and then 1, 2, 3, and 1. So 1, 2, 3, and 0, 0, 0, 1. So basically, like if you take the top right diagonal, like it's like the fourth one from both, you know what I mean, right? Like diagonal. It's basically like well, what that means visually, right? Is like 1, 2, 3, and 1, 2, 3. So right here, like see that? Like it's like connect 4. Like from here, you kind of like go here, 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 and we land up here, right? Remember, the coin started here, so it ends up here, right? So like this would be like 0, 1, 2, 3, and 0, 1, 2, 3. So it's a 3, 3, 0 index, right? And that's the current. So the previous game state is a 0, 1, 2, 3, 4, and 2, 0, 1, 2. So from 3, 3, then next one should be 4, 2, right? All right, so then let's skip to the next one, right? The previous one. Okay, next means previous in this case, right? Because we're doing previous after you're printing out the current ones first. So this was correct, right? Its coordinates is 3, 3, like 0, 1, 2, 3, then 0, 1, 2, and then 3. So 3, 3 is correct. Now let's see what, and then we don't have to pay attention to the other one. We don't care about the other ones. It's the first coin that matters. And here's the next image stack. So now 0, 1, 2, 3, 4. So it's the fourth one. And then 0, 1, 2, right? So this is correct. So right now, like the pointers are like, yeah, so this seems to be correct, right? That's good. Let's look at the next one. Just 1, 0, 0 on the fourth row, like 0, 1, 2, 3, 4. Let's make sure that matches just for my 0, 1, 2, 3, 4. Yes, so now as you can see, this one, yeah, so that's good. That works. Actually, why can't we just like print this as a string, right? Yeah, why are we making it like this? Can't we just like kind of like see it as like a string? Yeah, let's just make it as a string. Strings are nice to print, right? Yeah, let's just do that. I feel that's much easier. That's much nicer, right? Four. Same difference. Length, numbers, but yeah, you get the point. Equal, so let the row string be equal to, oh, we need to define C. Row string plus equals coin dot actually let's just make it binary because Or actually, yeah, let's just do like image RNC like that. 0, 1, but when the health change, this may look ugly. I know like this is kind of not most, like there should be some like string builder as opposed to like getting quadratic, but it makes no difference, small numbers. At the end of this, we just kind of, yeah, okay, let's check that out. This looks a bit ugly, dare I say. Line delimiter string equals to. No, this is a num calls deal. Okay. So now let's look at it. Right? We have like 0, 1, 2, like 0, 1, 2, 3, and 0, 1, 2, 3. So it's at 3, 3, right? After launching. But where it start off as 0, 1, 2, 3, 4, and then 0, 1, 2, right? Like if you look at like this one, so like you look at this one, and this one, right? And then this one, and this one, like this one, and that one. Like you see like these 3 ones here, you see those there, right? That kind of like shows you how like it starts, right? But then now like these are still the same. But then this one kind of moved a bit, right? It jumped from here to here. So we're able to see some movement. So that is very good. Get status. In fact, you know what? Let me go to the get ignore and kind of bring back Scratchpad. Let me actually delete this. How do I comment and get ignore, add a comment. Status, get add Scratchpad, status, clear, get diff, Scratchpad.ts. Okay, so that's just, we're kind of like doing that. GameState, we're just kind of doing a discretized coordinates. Again, we're only using it for our helper print method, which is this one right here. And this is only to be used in debugging. Like it has nothing, it's not actually used in Alpha 0. Now let's look at our net.ts. We just added 2 exports, logic neutral. We just export something. We don't change any function, just add the word export. So that's nothing too bad. Get status, get add all, and then get commit create a debug helper function game state dot print coins discretized. Copy, paste, just like that. Create a debug, debugging, debug helper function, GameState that print coins discretized. Get status. Okay, great. So now I'll push the off stream. So now we have this helper function, which we have like shown to work in Scratchpad, right? Like we in our Scratchpad.ts, we kind of are able to just kind of like query, like print the game states in a nice, well, nice is stretching it, but in a way that we can visualize it, right? So it's like we can visually like look at an approximation of our game state, right? Like we can't capture the exact stuff. I mean, rather than like read like coordinates of coins in like decimal form, we can just kind of visually kind of view the coins. So that's kind of pretty neat, and that's kind of like nice for testing symmetries. So I think I could just actually stop here maybe before actually like doing the symmetries. I think, yeah, maybe for now, like this is a super minor stream. We just kind of created this tiny little helper function. It's a very bite-sized work, but yeah, I guess next time we can kind of use this to like visualize the discretization. But for now, I'll just end here. So yeah, very little done, I know, but yeah, it's evening. It's a pretty late stream. Like I think that like in mornings I can do more. But anyways, so this helper function is done, and next time we're just gonna test our symmetries, and then yeah, we're almost like, I mean, who knows? In theory, like this all could be finished. I just have to run training, but like before actually running training, I want to like step line by line with every code, maybe like do debugs like I did for Connect 4 across the Monte Carlo tree search, and just kind of step through everything and make sure that everything is flowing properly, that everything, like everything is being done properly. And then once I'm kind of confident or like somewhat convinced on that, like I'm still shaky on symmetries, but like once I just kind of like, because like the thing is like when I run training, like it's very time intensive, right? And like if I find some bug, then I'll probably have to like train again from scratch. So like a lot of like that work gets thrown away. So it's better, I feel, to like kind of deliberately and slowly kind of do everything, iron out all the bugs, and then only then like get started with actually like doing the training. Or I could just be I mean, it's probably other reasons too, because I've spent like several months, well, on and off on this stuff, and like we're about to hit the moment of truth where we actually run training, right? Where we actually like get a playable bot, like actually do AlphaZero for BumperCoins. Like the good thing is I've succeeded in Connect 4, so like I've gotten like a pretty good playable AI, right? Like if you go to like bumpercoins.github.io and then Connect 4, right? Like the bot that I created, and like the source code again is public for anyone to see. Like the bot is pretty successful. Like it's decent, but like we have no idea if like the BumperCoins bot is going to be successful or not. So like if it isn't successful, then I basically kind of wasted like 5 months on and off. But yeah, so maybe that's why I'm a bit hesitant to run training, but we'll see. Anyways, like this is enough like kind of sad talk. I'll just end. I mean this should be exciting, right? Like just run it and then actually play it. And that's the whole point of all this, to see if like, yeah, just to see if this produces a decent bot. But in fact, let me just end it off like worst case, like at least I got like a working Connect 4 proof of concept for AlphaZero on this. Yeah, let me just play against my bot then. I'll go first. Actually, no, let's let the bot go first. I'll just play against my bot. Maybe I'll increase it 100. And I'll just play against that. And I'll just like end the stream off with the final game. And I will try hard to win. Okay, so it's kind of, I feel like this is a very natural move to play. I feel like maybe here to kind of like set up like the traces of something, or maybe here to block. I feel like here, I feel like it's better to do stuff in the ground, because like when new lines are populated, they're like dispopulated like from gravity down up. So maybe that might be the thing of choice. Okay, this seems like a dumb move, because like it's not like he can do anything, right? So I'm kind of seeing this in mind. I feel now is a good time to kind of block off some counterplay from there. Same thing, just kind of block stuff off. Okay, so then here, what's he trying to play for? Like something like that maybe? I kind of feel like going, here, then he blocks that. I could go here, but then he'll put there and possibly set something up like that. I'll just go here and cut off like something from here. Okay, so you put there, it's just intuition, I should block it. Okay, let me just put it on top. Okay, putting here would be a terrible mistake. I feel like these both are bad. I don't want to touch them. Here seems wrong, so I'll just put here then. Okay, so I think this is the move to cut off any of that, right? But by doing that, do I kind of sacrifice something? I give him this option. But I don't want to like lose like connect 5 and get humiliated. Yeah, I'm just gonna but if he moves here, I move here and then no. Okay, let me just block there. Again, I don't want to put here or here to give him some ideas, but unfortunately it looks like I'm gonna have to. Yep, he cut me off. So here's obviously really bad because I give him a double attack on there. So I guess I'm forced to put here. So me, him, me, him, me. Okay, good. I think it's a draw. Oh no, he puts there. Is there any threat? If I go here, what happens? Then he goes here. I don't want to go here and like give him this thing. Well, no, he can take it anyways by that. If he goes here, that looks scary, but either I put in column 5 or column 1. I can't put here because then he'll put there and double attack me and win. Okay, I'll just go here. This looks nice and central. He puts on top. Okay, well, I'm kind of forced to put there, right? And I cannot put here because he'll put there and then I'll have to block this, then he'll double attack and win. Oh, I think I just lost. Yep, I lost. So yeah, I mean, I just played a pretty, like, this bot took me to an end game and defeated me, so yeah, like, at least Alpha 0 works for the bot. So, like, hopefully it gives me something to work with. Again, like, this was like 100 Monte Carlo simulations to run this level of bot. And first of all, BumperCoins is way more complex, and second of all, like, the network is more complicated, complex, larger size, larger capacity, like just a bigger network. Like running it actually takes some time, right? So like in an actual real-time game, like when you're making moves, like your opponent has a fixed time budget, right? To actually like make some moves. So like the speed matters too, so they won't have enough time to run that many predictions. So like yeah, like, well, we'll see. Like, again, like, it's 60 ticks, like, in between moves. So, like, the bot has 1 second, right? Like, 1,000 milliseconds to work with. That's its time budget, approximately. So, yeah, we'll see how it goes. But anyways, the point is that, like, next time we'll, like, use the scratch pad to test out the symmetries, use this printing function, the visually printing coins discretized, to test out like the all the 3 different symmetries: horizontal, vertical, and horizontal plus vertical. And then after we test those symmetries, well, we'll take it from there. I think that might be like the next stream, just the symmetries alone. So anyway, I'll just stop now. So yeah.